What if I told you that I had a pattern you could use to make any code that you're touching more testable than when you got there? Well, in this video, I'll show you how so that you never have to go check in code without tests. Testable code is a big theme on my channel and also in my career, so I want to start with a story here. I've worked at both startups and in big tech, and this is a common thing that I see across the board, so it's not just restricted to new, smaller companies working in brand new code bases, and it's not restricted to companies with just legacy code. This comes up all of the time when people are making changes and they happen to be inside of an area of code and they say, well, I couldn't add the test because the code just isn't testable. And an even more dangerous thing is that as this pattern propagates, you have people continuing to commit code to an area and saying, well, I can't test it because it's not testable, the previous parts weren't tested, so on, so forth, more code added, no tests added. If you fast forward over time, what ends up happening is that this usually becomes a brittle area of the code. No one's excited to go make changes there because things often break, and you find out in production from a user and not from your tests. So in my travels, I got tired of hearing this because I figured there must be a way to at least make what you're changing testable. This pattern actually came from working directly with testers more as strategists and less about running test cases manually. So by having a lot of trust between our engineers and testers and a high degree of collaboration, what we came up with was this scenario where we would say, look, like I fixed the bug, and it might be something that's really difficult to reproduce, and we'd be able to kind of walk through the different things that the tester might be looking for, and then we could actually go show them that I've created code that will go cover these tests. And because in some cases we were working in legacy areas of the code, or we were working with systems that we didn't actually directly control, so say that we were fixing a bug for a customer, and that's not something we could reproduce locally, a tester would have a lot of difficulty going to try and prove that it worked, but we actually had some superpowers because we could say, look, if I can demonstrate to you in the code this is how this exception occurs or whatever the situation is, now I can show you with test coverage that it's there and fixed. So with this pattern, what we're actually able to do is add test coverage over the changed code, but what I'm not saying here is that I'm going to fix all of your legacy code base and it will allow you to test all of it at once. What we're going to be doing is isolating the parts that we're changing so that we can test those, and that way you're leaving the code in a better spot than when you got there, and the changes that you're creating actually can have tests, and there's no longer an excuse to say it can't be tested, because it can. The rest of the code at that point in time maybe cannot. So if that sounds interesting, let's jump into Visual Studio. I'll walk through an example and we can see how this works. All right, I'm here in Visual Studio, and what I've done is created something like a legacy system. I've also left this big comment at the top that I want to pause and make sure we take a moment to read, because when we're creating content like this and putting it out on the internet, I don't want people that are maybe skimming through stuff to see some of this code and go, oh, that's how that works. That's how I should do it. In fact, this is an example where it's the exact opposite. So my disclaimer here is that this code that we're about to look at is absolutely something I would not recommend you follow. And that's because I'm just trying to demonstrate with this example that you have come across a change you need to make in a legacy system. Its legacy hasn't been touched in forever, so people have learned about how to do things better. So there's going to be some things that you would probably not do if you knew better, and that's okay. And the point here is that we don't have to go touch all of the code to go make a fix, and we don't have to go fix up in Boy Scout or Girl Scout all of the code that we're looking at just to be able to make our change and add some tests. Over time, as this becomes more and more testable, certainly you could go take that approach. But my point here is that I just wanted a disclaimer because some of the stuff we're going to look at, some of the stuff even right here, like I would not recommend you go write this in your code to accomplish what these things are supposed to do. So with that out of the way, let's look at this legacy system. It's definitely just a super contrived example because like what we're going to look at here is not really a real thing, but I wanted to kind of use some things that generally make it harder to write unit tests. So the reason that I want to look at making things unit testable and not necessarily like how do we make it more functionally testable or able to support by integration tests is because when we have legacy systems, Sometimes, depending on what's making it legacy or what some of the code there looks like, actually writing integration tests over it might be very challenging because you don't have control over a lot of the pieces. So, for example, in this case, I'm not connecting out to a database or anything, but if you had a legacy code system and you did not have control over how that database connection was set up, you're going to have to do refactoring to be able to have some control over it because maybe you don't want it to go directly to production, that kind of thing. So if we can focus on making things unit testable, this way when we make our changes to fix bugs or add features, whatever it happens to be, whatever code we're directly touching, we should be able to go ensure that we have unit tests over that directly. Again, over time, as you start to follow this pattern and this practice, the more and more that your legacy system ends up becoming broken apart into smaller pieces, this might allow you to functionally or write integration tests over these pieces more easily. And that's because in isolation, they're now testable and that's because in isolation, they now have unit tests over them so you can ensure their functionality within their methods and classes. But beyond that, now you should be able to kind of write the integration between them. When it's all set up in some type of legacy system that was never really thought through to be testable, that can be really challenging. So in our legacy system, we just have this one public method on here. It's just do something async. What we're going to be doing is actually working with a blog post, but the point of what we're looking at is not actually the work in particular. It's just so that we can point out where we find the bug, how to fix it, and how to write tests for it. So when we're thinking about things being unit testable, there's a couple of things that kind of stick out to me that I never like saying, you can never do something, you should always do something, but I have guidelines. So when we have things like static methods to access the file system, generally this makes it harder to unit test because in a true unit test, you don't want to be working with things outside of the code. So going out to the file system generally is kind of going, around the boundaries of a unit test. You can still absolutely write coded tests. In your perspective, that still might be within a unit of work. But in my opinion, once you start touching the environment like the file system or going to the internet over the network, that's kind of going outside the unit that we're testing. So static methods for the file system, generally not so great, make it more difficult. Using date time now, so again, static properties to access the current time. It's not that this is impossible to test around, it's just that it makes it a little bit more difficult because if you can't control the current time, it makes it really hard to force the code execution to go into this path and actually have assertions that will check what we're looking at here. So again, common theme is that static methods, static properties, it doesn't mean you can't use them or you never should or anything like that, but think about your usage of them when it comes to testability. So in this case, we're just saying, hey, is there a no blog file here saved as an HTML file? Or I guess in this case, or if it happens to be a Saturday, we want to go get it anyway. So then there's this method to get some blog article. Now, the code after that, we'll jump into this in a moment, but the code after that, starting on line 18, actually tries to read in the text from the blog HTML file. It's going to call this process HTML a sync method with that HTML and get it back out of that method. And then it's just going to go write out that HTML again. And you'll notice that I have another static method to go right out to the file system. So just like above, this can make it a little bit trickier to go, write true unit tests over top of it. So the reason that I planted these things into the code was just to kind of show you that these are usually practices, again, another static one here, that make it a little bit more difficult to actually write unit tests over. Doesn't mean it's impossible, doesn't mean you can't write other tests, but it generally makes it a little bit more of a hurdle. If we go look at the process HTML async method, you can see that we're just passing in that string. I wrote a comment here saying, I'm not actually going to go write a whole bunch of logic for this example. We're just going to lower it, but assume that, we had some method in some legacy code base that actually had to go operate on this HTML. The body of this code is not super important. I just wanted to illustrate that in a real program, you might be doing some other work here. Now, the other method we have is get some blog article. Again, I used static here, and at this point you might be going, wow, this guy really hates on the static keyword. Not necessarily. I just, like I said, I think that when you have stuff like this, it can make it a little bit more tricky to test. This is a private method, so in the first place, it's a little bit trickier to actually directly test. If our class was small and the method in this class, the calling into here, was also pretty small, then perhaps this isn't so difficult to work with, especially if we had dependencies that were passed into this method. That wouldn't be so bad either because we might have control over them. So another thing for testing and testability is that when you start newing up instances of objects that you don't have control over, right? So from a unit test, you would never be able to mock this out or have direct control over it. You kind of just need to let it do what it's got to do when the code's executing. This is kind of like a static method in the sense that we don't have control over it. So this is one thing that we have right at the top of this method that's going to make things a little bit trickier for testability. You'll notice too, this is a static void method. This is an async method. I'm not awaiting it. I'm just saying get the awaiter, get result. So interesting, right? Why would we do that? I don't know. This is legacy code. Someone wrote it and they didn't know any better. And then I planted a bug directly in this code on line 40 and left a comment there. And what we're doing is, because we're pulling a page from my blog, we're actually going to replace dev leader with some total nerd. Obviously, that would be a bug because that's not cool if someone were to do that. And we would want to make sure that we can fix this up. At the end of this method, we're going to write all text for blog HTML with this value here that is literally what we pulled from the internet replaced with this part here. You'll note too, another usage of static for write all text. So just a common pattern throughout this whole thing, static methods, and then newing up dependencies that we don't have control over make things a little bit trickier to test. So let's talk about this code for a moment. If we know that the bug is right here, right, and right now we don't have any tests over this class because it was really hard to test when it was originally written. No one wrote tests because they were like, hey, I don't know how to mock out this HTTP client because it was newed up. I don't know how I'm going to mock out all this file system interaction because it's actually touching the file system. Gee, I had to use date time now. I'm not really sure how I can control the code execution path coming into here. And then they said they couldn't write functional or integration tests over this class because maybe their continuous integration system doesn't have internet. So it was just left, never touched, and never tested. But if we look at where the bug is, if we said, well, to fix this bug, all that we have to do is go remove this code. Now the question you might be asking yourself, or if you're working with other people on your team and talking about test coverage, test strategy, that kind of thing, is like, well, you've fixed the bug, right? You might be able to go run this locally and say, cool, it all does what I expect. It no longer says this guy's a total nerd. So how do you prove that that's actually fixed? And how do you prove that you're going to have regression coverage over that type of thing, right? So the regression coverage doesn't necessarily have to be like, hey, look, it will never say this guy's a total nerd again. But you might be able to say, like, we would have caught this bug if we could have actually tested some things about this method in the first place, and that way we wouldn't have that bug slip in. Well, if the only part of the system we actually touched was right in here, in theory, to make this just a little bit better, all that we would really need to do is write some test coverage over this method. Now, you might be sitting there going, well, Nick, that's not going to prove that the other parts of the code didn't break, and this is still all going to be untested, and you're absolutely right. Like I said at the beginning of this video, the point of this strategy and this process is not to actually make everything more testable all at once, and it's not to make a claim that by writing these tests, all of a sudden you're going to have 100% confidence over all of your legacy code. What the point of this is that you can make changes inside of any legacy code or other hard to test areas and make your changes specifically more testable. So the pattern that I like to use to get started has actually already been performed, but I want to talk about it because it's usually a good first step. Because our code that we wanted to fix up is inside of this small method already, it's kind of already done for us. But if it were, say, something like maybe this line here, line 18, if for some reason this was the line that I needed to change or make adjustments around, that might be inside of a bigger method that I'm not going to be able to go test all at once. And I might want to isolate just the part that I'm touching. So what I might do is go pull that code out. I'm not going to necessarily pull out a single line, but just as an example, maybe it was this much code. I might go pull that out into a method. So in our case, we actually already have a nice little method now. This one is pretty purpose built. It's just going to go fetch a blog article from the internet and write it to disk. Like technically, you could argue that's doing two jobs, but you could maybe make the argument that, hey, the single responsibility here is translate internet article to file on disk. So cool, that's pretty close to single responsibility. That feels pretty good. And maybe we could go look at testing just this now, because now we know that its responsibility is to go pull an article from the internet to save it to disk. And that way we can go make sure that it works as expected. And if I pause there for a second, if you think about what I'm doing is I'm just kind of decomposing all of the responsibilities in this class and looking at the methods and saying, can I now have it at a point where I can prove that this smaller piece, right, we're just making it into smaller pieces, can this smaller piece be tested? And this process almost becomes recursive in nature because now we go look at just the code that's highlighted and we go talk about some of the things that I said earlier that make it hard to test or easy to test. So in this case, we're newing up an HTTP client. So again, that's going to mean that I don't have control over that from a unit test perspective. It means it's truly going out to the internet. If we were thinking about, cleaning up the code as we're going, so like that Boy Scout, Girl Scout kind of approach, well, this is not an async method, it's a static void method, and we're kind of just cheating and not using the async await part. We're just getting the awaiter and getting the result, so that's not super great. And then the other thing is, like we said earlier, this static method. So if I were having a conversation with someone on my team and saying, look, I want to change as little as possible just to prove that I fixed this and write tests, for me, this actually might be okay to totally leave in there and say, look, I can actually just go make an assertion in the test that will say, hey, look, this blog article has been written out to the file system. This part up here, I might not be so comfortable with. And this might depend a lot on how your test infrastructure works, right? If your team or you are totally cool with having tests that go fetch data from the internet, you're willing to assume that this resource is always going to be available, that kind of thing. Like, I don't think that's necessarily a great idea because, well, unfortunately, my blog has gone down and you don't want your, integration suite for your test to just start breaking builds because of something like that. If you're comfortable with it, I'm not going to tell you no, but in my code base, I probably would not be trying to do that kind of stuff that would, gate builds especially. So I might try to leave this in place. I might look at how we can mock something like this out. And then one of the little things I might clean up is if I can make this async await instead of void. And if we check out the only spot that this is called, well, it's already async, so that might be okay to clean up. So at this point, what I'm going to do is I'm just going to copy this method. I'm going to comment it out, and I'm going to say old. And I just want to leave that here, so if we need to refer back to it, we can. I've now pasted the method again, and I'm just going to delete the code where the bug was. So this is what we were just looking at, and I'm going to leave some comments in here that say what we're going to try to clean up. Okay, so I've just left a comment here talking about the HTTP client, so something we can do to not go to the internet, talking about making it async await because that seems like it should be a little easy win for us. And then the other thing was, if we can, not actually going out to the file system. So what I'm going to do now is I'm going to go add a test project, make a little bit of a setup so that we can call into this, and then from there, we're going to start refactoring the code. So I've created a test project and we're going to be using xunit here. So if you're not familiar with xunit, we can mark our test methods with this fact attribute. And I've made other videos about this and I'll just show you briefly because I can link above. But if we check out the project, we can see that I have these package references here. This is what I use for setting up my tests. I know that some people are going to see this line right here and especially all of the information from the recent weeks. People are probably going to be upset about seeing that. I'm still sticking with mock. I mean, do what you want. I'm just comfortable with this, and I'm not really trying to jump into all of the drama. So you don't have to use mock. You can use whatever you want. But xunit is the preferred package that I'm using for my test framework. And let's jump back over to the tests and think about how we want to go test our class. Now, given that this is a legacy class, I did call out earlier that we're not going to be able to go tackle the entire thing, right? So the goal here is not to go say, how do we run tests across the entire legacy class? Because I actually tried to design it such that it would be difficult to do so. But we did make changes to one method, and we should be able to try and at least write coverage for that so that we can talk with people on our team to say, hey, look, I fixed the bug, or if you're delivering a feature or something else, you can at least say, based on the code changes I've made, we now have test coverage that we didn't have before. Now, if you recall, the legacy system did have a method called do something async, and we can await this, but that means that we have to change this to be an async task as well. And you can take note here that I didn't actually name the test yet, but we'll get into that as soon as we get a little bit further. Now, the challenge that we have is that this is the only method that's publicly available on legacy system. And that means that if we want to go testing just the method that we were working with, we actually don't have access to that. And this is where some slight refactoring is going to come in. And like I mentioned a couple of times earlier in this discussion, we can take this approach and start reapplying it for different scenarios and kind of this recursive pattern. So if we jump into this method, right, this is what we were looking at before. This is the method that we ended up fixing up to remove that line that was the bug. And this is actually what we want to try testing. So my recommendation, and this is where you can't apply this necessarily as a blanket rule all of the time without thinking through it, but what we want to do is actually pull this out as a new dependency. The reason this takes some thought process, if you kind of extrapolate what I'm talking about here, if you were to try removing just one or two lines all of the time from your legacy code and try and write some tests on it, you're probably going to run into this situation where instead of one big legacy class that you can't run tests on, you might have 100, 200 classes that are tiny that all have test coverage on them, but they're totally incomprehensible with how they all fit together because they're just not thought through. So that's one of the drawbacks of this if you don't put some thought into it. But like we were saying at the beginning of this, because we took this method and we were saying, actually, this does actually have a single responsibility, which is to go fetch a blog article and have it on disk, we can say maybe we want to go have a blog fetcher class that can fetch a blog. So what we're going to do is pull this method right out of this class. I'm going to introduce a new class. Right, so now that we have this new class, we can drop our method in. And now that we have our method on here, what we can do is go public void get some blog article. Now all of a sudden, we're in a situation where this code is isolated, and we can start to talk about how we test this directly instead of all of the legacy code. So this is an important checkpoint because this is the concept that I want us to be able to apply over and over as needed. And again, we want to think through whether or not we have small classes that actually make sense, because you might want to group some things together as you're moving along. One other thing to note is because we pulled this out, the other code is actually broken. But that's okay because we can fix it up just by passing in that dependency. So let's go ahead and do that. So to pass in the dependency, we have a field, and then we're passing in through the constructor a blog fetcher instance. And then all we want to do is use this blog fetcher at the point where we're calling the method. And now all of a sudden, we've isolated this bit of code, the blog fetcher, that has our method that we touched from the rest of this legacy system. And if you think about it, we're not actually going to be writing tests over this part of the code, so that's still going to remain untested. It's still going to be something you're going to want to have a conversation with the team members about to make sure that you all have confidence in this change. Because yes, this is a contrived example. Yes, in your situation, it might be a little bit more complicated. You might still have to touch a little bit around here, but at least you're adding net new test coverage, especially over the code that you're touching. Let's jump back over to our tests and actually change the fact that we're not going to be testing our legacy system. We're actually going to be testing a blog fetcher. All right, so blog fetcher gets newed up here on line 10, and then on line 11, we actually call get some blog article. But recall, one of the things that we were thinking about tweaking as doing some Boy Scouting or Girl Scouting was that this is not an async method. Well, let's go ahead and adjust that right now. I add async task out the front here instead of void, and just because I like to stick to this naming convention, I am going to stick async on the end of this. So it's now get some blog article async, and we can actually look at changing this to write all text async and awaiting that as well. The other part that we called out from before is, of course, that we don't want to have this get await or get result. So let's go ahead and backspace that, and we can actually await this part here. And just to fit a little bit more text on screen, I'm just going to split this string across a couple of lines. Okay, so what we've done so far is we've now made this part async await, so let's cross that off our list. Now, we still have an HTTP client used here, and we still have this fact that we're touching the file system, but we did say that we might come back to this one, and based on our types of tests, we might leave this one still, because realistically, just writing the file to disk, we might be okay with that. Now, a quick note before I forget is because we did make this async, we are going to want to go look at where it's used again and actually change that to be awaited. If you recall from earlier, I did say that this might be an acceptable change because this method was already an async task, and if we're already right here, we might be able to just await that and get some goodness out of doing that. If we go look at our test and we await this line, we'll want to do the same thing on our test, and if we think about what we have written here now, we're actually in a test method that can go call this method, and that's great, but now we want to think about how we're going to assert what's actually happening. So two things going on are, one, that when we call this, it's still going to go out to the internet. That's one of our line items to address. And number two is that we're going to want to see if we can validate the file that's on disk after this or look at mocking that as well. First step is going to be addressing the HTTP client. Generally, the strategy that I like to use when I see this type of situation here is I like seeing if there's an interface already implemented on the object that I'm dealing with, and that way I don't require that I'm dealing with a whole new instance and that my method is responsible for creating that instance. So if we go press F12 in Visual Studio to go look at the definition of this, if we look at the class up top here, HTTP client, and then message invoker up top here as well, well, what I'm actually interested in seeing is if there are methods that allow us to get strings, or if we have to go dig a little bit further to see if there's an interface that implements these. And currently what I can see is that the methods are actually implemented directly on this class and not part of an interface. If I do look at the class it inherits from, there's a little bit of proof here that we only go up to iDisposable and there's no interface in the class hierarchy. So that's going to mean that we can't actually just go pass in an interface for iHTTP client because there isn't one. And that's okay. In this particular case, just to demonstrate an example, all that I'm going to do is show us repeating this exact same process, but for an HTTP client. And again, I just want to call out that I'm not necessarily recommending you do this specifically for an HTTP client. In my opinion, if you want to look at mocking out your web requests and things like that, there are other solutions you can do instead of rolling your own wrapper every single time you want to deal with an HTTP client. But let's have a little look at just a simple solution to walk us through this. All right, what I've done so far is that I've made a new class called an HTTP client wrapper that takes in an HTTP client and calls a method getStringAsync right on the HTTP client. And that's because the only thing that I'm using in my existing code is getStringAsync. From here, because I'm using mock and we're not using some of the newer features of dotnet that are coming, which allow interception, the way that we look at mocking currently has to deal with interfaces. And lots of people have different opinions about overusing interfaces. Personally, I do like using them for testability and mocking. It's one of the strategies I find works really well for me. This is something I talk to other people about so that they have that tool in their tool belt to be able to go use. But of course, you should find what fits for you. In this particular case, we're going to look at pulling out an interface from this client wrapper. And just by adding that interface now, we can see that we have iHTTP client wrapper. I'm going to rename that just so that it says iHTTP client. And we have this single method getStringAsync. So now you might be saying, well, Nick, this part is still not testable. If we were to call anything on here, we're still going to go out to the internet. And you're absolutely right. And what we're going to be looking at is the same concept that we talked about in the beginning. We're not trying to test every single piece of this. We're just trying to isolate our code so that we can write code over top of it to execute our changes specifically. So the end result of all of this is that we're not going to be testing any web request stuff, not with our unit tests at least. What we are going to be able to test is that we have some flow over this method that does what we expect. So now in this case, our blog fetcher will take in a new dependency. So we'll pass in the iHTTP client, and then we're going to replace the HTTP client usage with our new interface. Okay, awesome. So now we don't have a concrete HTTP client in here. That means that we can technically go write a mock for this and not go out to the internet if we don't want to for this case. So what we're left with is something that's going to call a mocked interface for an HTTP client, and we still have this write all text to disk. We are going to leave this writing to disk, and the reason that I want to leave this at least in place is that I think some people watching this might say by the end of it, well, there's actually nothing left in here. What are you actually mocking? What are you actually testing? And I think that's a valid point. Generally, I would probably try to clean this up as well, just to prove that I don't actually have to go manage files on disk between my test runs and things like that. But if we go do that, we're just going to be left with two dependencies we're mocking out, and it might feel a little bit silly to some people. So let's go ahead and jump back to the test and see what we can do. Our blog fetcher now takes in a dependency that we're not passing in here. So I'm going to go ahead and create a new HTTP client, but we're not going to pass in the HTTP client wrapper like this. And that's because if we go to create it exactly this way, what we're left with is still going out to the internet. Instead, we're going to use mock. And like I said, if you're not a fan of mock anymore, you can go ahead and use some other library. That's totally fine. The concepts will still apply. So I start by creating a mock repository, and I use strict on here so that I can ensure everything I've set up is actually correct. Line 13 now actually creates the HTTP client mock, and that means that on line 15 we have to make a slight adjustment, which is actually passing in the mocked object property. At this point in time, we could technically go run this test, and what's going to happen if we were to go run it is if we check out what this method actually does now, by the time we hit this part of the code right here, we're actually going to get an exception. And that's because we didn't actually set up our mocked HTTP client, we just created an instance of the mock. So for us, we're going to want to actually ensure that we have this set up configured properly in our test. We can talk more about that in a moment. And then the other part is that it's going to write out a file to the disk once this mock setup's actually working. If we jump back to our test, we can think about how we want to actually validate the output. So two things I'm thinking about doing are, number one, checking to make sure that the file exists, and then the other part is we can talk about actually reading in some of that text and doing something with it. Now again, this isn't necessarily something I would be trying to do in these tests. I might not try to be interacting with the file system like this if it were something like a true unit test. In your situation, if you're finding different ways that you can at least get test coverage on this code, then I think that that's way better than nothing. Again, for this type of thing, you'll want to consider how your tests are structured and whether or not this is applicable for the area that you're working in. All right, so what's left in this test is that we probably want to consider what it means to be valid when we go to read in this result. And the other part here is that we have a mocked HTTP client, this wrapper that we made, and we're going to have to set up that mock such that when we exercise the code inside of this method, it behaves how we would expect. Now, just a quick note on mocks and how you can use them for your test setup. Generally, one of the things that I really like about mocks is that you can control the behavior of your dependencies. And that might sound really obvious, and it's not going to be demonstrated very well in this particular example, but if you needed to be able to control your logical flow to go across if statements, so for example, if some HTML came back as null and you wanted to throw an exception or do some other type of processing, right? I don't know, maybe you want to set it to some default value, whether it's empty or you want to put whatever in here. When you're able to write unit tests with mocks and you can control the different results that come back based on conditions, you're actually able to force your code into certain paths. And in our case, it's not really going to be applicable, but that's generally the idea why I do like being able to write unit tests. And I say this all of the time, but I like writing unit testable code, but it does not mean that I go write unit tests for absolutely everything. In fact, it's pretty rare now that I am writing unit tests, but if I find that I need to go back and actually force some code execution paths, I really like the ability to be able to do that without having to refactor all of my code at that point. So just a heads up, that's why I like writing unit tests with mocks, but we're not going to have to do that in this particular case to control the flow. The mock we have to set up is going to be this HTTP client, and specifically this getStringAsync method. Now, because this is a pretty contrived example, I did hard code this string in here, but that means that in our setup, this is the only string that we need to look for. In fact, any other string that was passed into here, we might consider that a bug actually. So when you're thinking about setting up your tests, you can consider whether or not you want it to be valid for other strings to come in here, or if you do actually want to guard against that. The other part is that our mock is going to have to return some HTML. So let's go back to the test and set that up. This setup right here is by default when I used Copilot what it just spat out for me, and I just want to talk about it quickly because I think it's close to what we want, and in fact it might be okay for this example, but I just want to speak to this it.isAny part really quickly. If you recall, I said that we can only expect one URL to be passed in at this point in time. Now, if you consider that behavior expected, that it must always be that exact URL, then I would highly recommend that you do not use it.isAny, but instead you actually put in the string that you expect. So in this case, instead of putting it.isAny, we would actually go put that URL in. And that way, if anyone came through that code and they changed the URL in any way, our unit test would actually break. And that's to guard against accidental changes because we're saying we actually expect this exact URL. But in this case, just to make things really simple, I'm just going to leave it as it.isAny, but I just wanted to call out that that's why I do it that way. The other thing we'll note here is that it returns async and the string that comes back is some HTML. And what's interesting here is that given that we know the actual structure of our code that's being executed, we don't actually need it to be real HTML. We can kind of do whatever we want here because the reality is whatever's here on line 17, that's what we should be expecting read back from line 23. So in this particular case, this is what I would expect because the only thing that we end up doing is taking this result directly from the HTTP client, writing that out to a file, and that should be exactly what's inside of the file when we read it back. And just to wrap up this part for the test, one thing that I always like to do with my mocks is actually call this verify all. And the reason that I call verify all is that if over time you're refactoring code and things are changing, if you had extra mock setups, say something like this, and we had another setup here that was some other URL, and at some point in time, if it was valid to have both of these setups like this, if you didn't have verify all, what could happen is that over time you have all of these extra setups that might exist, and if you're not cleaning them up, they never really go away. But with verify all, if this one's actually not getting called, verify all will tell us and actually fail the test, and it will say that this mock with some other URL was actually never called. So it's not that the logic under test has an error, it's actually telling us that our test has extra stuff set up. So at this point in time, I think that this is actually a test that would cover our behavior that we have inside of this method that we pulled out into a new class. This is a little bit of a silly example because the bug that I was trying to prove is fixed was actually just some silly string replacement, but in your particular case, you might be able to reflect on the code that was being changed and actually do some other types of assertions here that prove that things are working as you expect. When it comes to naming this, I might go change the title to get some blog article async because that's the method that's going to be executed. The next part is generally where I would put some type of conditions about the setup that we're looking at. And then the last part is just some string that's going to tell us a little bit about our expectations for the result. This might not be the best naming for this particular example, but I just wanted to demonstrate that instead of some placeholder text. If I go run the test, we can actually see that this test now passes, and that's awesome. And it's not really that complicated, but like I said, this is just to show you the pattern for pulling the code out to be able to test it. Before summarizing this video, let's have a quick look at what our legacy system is left looking like. And this is going to be something that you can think about for the conversations that you either want to have with testers on your team, or if you don't have dedicated testing roles or anything like that, you can talk with other software developers to make sure that you feel good about the coverage you have. Now, the bug that we identified had nothing to do with this particular method right here. And like we talked about in the beginning of this video, This method, we were saying, hey, look, it's a lot of legacy code. It's going to be hard to test it because some of these static things, we have some things that are specific to the time. It's just going to be a bit of extra work to try and clean all of this up, and we'd have to refactor and rewrite basically the whole method. That might actually be okay in this particular example because it was pretty small and pretty crappy code to begin with. But if you had a bigger legacy system, the point here is that we're trying to leave this part mostly untouched. And unfortunately, in our particular case, this code didn't get any easier to test, so we didn't end up adding any extra tests specifically over this method. So this is a point you're going to want to talk about and say, hey, look, like I made changes and this code path is going to call them. Now, I wasn't able to test this code path still all up. However, the part that I changed in particular, I was able to write tests on. And what we did was, because that code was actually already pulled out into its own method, if we scroll down a little bit, this is the old one that existed, right? We actually pulled that out into an entirely new class, and it's sort of a purpose-built class. And that was so that I could demonstrate some Boy Scouting and Girl Scouting kind of cleanup that we could do. Very minimal for the async task part of the API there. That way we can async await it, because the original code was a little bit gross. Then we actually looked at changing up the HTTP client so that we could inject that into here as a mocked dependency for our tests. And again, people will have different opinions about this. Newer .NET versions will actually allow you to use interceptors there and not require interfaces, so lots of different options on the horizon. That's totally cool. But in this particular case, we now don't have to go out to the internet when we're running our tests. But one thing we left in place here, and this is where I was trying to say, hey, look, this might not be something that I always do, but we didn't actually have to go refactor and pull this out and sort of do the same thing where we mocked out that behavior. I kind of drew the line at saying, I'm okay to interact with the file system. Sure, it's kind of breaking some of my air quotes here, unit testing principles that I like to follow, but it's still allowing us to get some test coverage on this method. So if we're talking within our team about if this method is working better or not, well, sure, we're not actually proving again with the unit test that it's going out to the internet. Quite literally, we made a choice to mock it. But you might be able to explain to your colleagues, and even for yourself to have confidence, that the wrapper class we created is literally just a direct call into the HTTP client, so no custom logic there. And I mean, looking at the URL, if we thought this was working before and that wasn't the problem, it should still work after this refactor. If people weren't happy with that, you might be able to say, cool, maybe we do want to put an integration test on this. Maybe you do have a test suite that actually allows you to go connect out to the internet, and then you don't need a mock. You could actually just call this thing and have it connect out to the internet, and everyone's happy with the test coverage. That's for you to decide within your team. And then because we pulled out the line of code that was doing the silly string replacement that was demonstrating the bug, we actually don't have an issue anymore. And our test actually validates that whatever comes out of this HTTP client, regardless of whatever it is, that's going to be exactly what's written out to the file. So if we jump back to the test super quick, that's why this part here that actually reads in the text from the file equates it to exactly what's returned here. So to summarize in this video, we looked at a pattern and practice that we could follow that would allow us to go refactor code to pull it out of what would be considered legacy code. I came up with a really silly example to demonstrate this, but I'm sure you've come across some legacy systems in your programming experience already where you were like, holy crap, I don't think I can test this. The idea was really just about extracting code so it could be isolated, and then there we could go run tests over top of that extracted code. I demonstrated this with something close to a unit test, showed some code improvements we could kind of make along the way, but I just want to call out, you're not forced to write unit tests to do this. Please use the tools that make sense. If that's unit tests and that's what you follow, great. If you want to write integration or some other type of functional tests over top of that, because that gives you the confidence you want, by all means do that. The entire point here is that we could actually isolate that, because that's where our changes were, and then run tests across it. What we're not doing here is proving that we have the rest of the test coverage across the legacy part of the code. So yes, there are still untested parts here, 100% not trying to claim otherwise, but I think that's a really good conversation opportunity that you can have within your team and try to build confidence along the way. So you can demonstrate to your teammates, hey look, we're cleaning this up a little bit as we go. Yes, it's not fully covered, but it should be net better than when you started there. So I hope you found this insightful. Thank you so much for watching, and if you have any questions, please leave them below, and I'll try my best to answer. Thanks, and we'll see you next time.